very urgent, which I thought of covering. So I wanted to actually finish off this IP part today, but I'm not sure, because we have lost some time. I do not know, so whether we will be able to do it or not. In the meantime, I will try to fix the problem that I am encountering. So anyway, so let me go ahead. I'm just taking help of the PPT because I do not have the facility to use that device that I have to explain to you. So I hope that my slide is visible to you.
Yes, sir.
Yeah. So, do you remember that when we were doing this IP address subnetting, etc., at that time I told you that there are two types of, um, two types of addresses, right? So IP addresses, IPv4 addresses, you can have classful addressing, which we have discussed, and also we talked about this classless addressing, right? So in classless addressing, as we know, that there is no class A, B, C, D, etc. And basically, with the help of this prefix, etc., you try to do a match about whether an incoming packet belongs to a particular network or not, right? So that is the classless addressing. So continuing that, so that's if you recall that's CIDR, right? So it's called classless interdomain routing. That's called CIDR. That's the acronym. Okay, so yeah. So along with CIDR, actually, there is the concept of supernetting, and this is the part actually for which I have to actually write and explain to you. But today I'm not sure how much I would be able to do it. So irrespective of that, I will try to find some other time to do this part. But let us go ahead and see, how best I can do with the help of slides only. So if you recall, this is something that's what we covered before. So if we are talking about an IP address, right? The IP address has, so first of all, if we are talking about 32-bit address, that means IPv4. So this 32-bit address, you can split it up into two parts. One is the prefix, the other one is the suffix, right? The prefix part basically helps you to define the network, and the exact node, etc., the host, etc., so those things are basically defined with the help of this suffix, right? So if this prefix part is n bits, obviously the suffix part is going to be 32 minus n bits. Okay, and so this is how basically this IPv4 address can be partitioned into two parts. One is the prefix defining the network, and which network. So this basically dictates like which network a particular packet belongs to. Okay, and the suffix basically so defines the connection to the node or the hosts, right? So the exact host to which it belongs, so that's what you get from the suffix part. And yeah, so when we talk about this classless addressing, okay, so in classless address, actually you do not have that sort of thing like 255.255.255 dot something, that sort of mask is not there, right? So here basically what you have, you have all these IPv4 octets like this, and then you have this /n, right? So this n basically defines the prefix length. Okay, so this is the prefix length. So this length, basically this prefix length, so how many bits from the very beginning will define the prefix, and the rest of the bits are going to be the suffix, right? So 32 minus the number of bits which are defining the prefix is going to be the suffix part. So this is a recap of what we have covered earlier. So we have already done this. Now let us try to understand the supernetting part. Okay, so the supernetting with the help of CIDR is interesting. Okay, and this is where actually I wanted to do some handwritten work, so which I am not able to do now. So anyways, so uh, so the routers basically, so supernetting. So first of all, you need to understand what is supernetting. So we know what is subnetting, that we have seen. So subnetting is basically, you take a network and you want to divide it into smaller parts, right? And why do we need to do subnetting? Because basically, so IPv4, right? IPv4 is 32 bits, right? So 32 bits means 2 to the power 32 bits, 2 to the power 32 addresses are possible, right? And that is not sufficient to cater to the growing number of IP addresses that are required in order to have this ever-growing internet. So what these people did, they took help of many different concepts, one of which is the subnetting. So in subnet, basically what you do is the service provider, they give you one kind of address, and then you one kind of public address, and then what you do is you take it and you break that network into smaller networks, and so like that, this is one of the mechanisms. So subnetting, and there is another one also which is called the NAT, right? Network address translation, which I am going to explain in a little bit more detail shortly. But these are like different mechanisms. So subnetting, we understand that taking the bigger network and breaking it into smaller parts. Now the question is, what is supernetting? The question is, what is supernetting? So supernetting is kind of conceptually the opposite of subnetting. So in supernetting, what do? You take the smaller networks, okay, and then you form the bigger network out of those smaller networks, okay. So what do what does it exactly mean? So why do you want to do that? Because you see, supernetting, so many times, you see that internal to the organization there may be different units, different departments, etc., right? Or maybe you might also want to have multiple different organizations, so maybe different campuses, etc., so all of which you want to put under the one umbrella, okay. So to the external world, all these smaller networks are going to be known as a single entity, okay, under one umbrella. But internally, actually, you have the mechanisms that if that gateway router gets it, then it knows how to handle that particular packet and send it to the respective smaller network. But you see that to the outside world doesn't want to know, it is not required that which particular department, etc. So the outside world doesn't have to send it to the exact department. It can send only to the IIT Kharagpur network, for example. So let me give you an example. Let me give you an analogy of supernetting. So let us say, think postal system. Right? Somebody in Germany wants to send a a letter by post to me, and I am in Kharagpur. Okay. So you see, the German postal system, by looking at the address on the envelope, which is an Indian address, doesn't really have to bother to know where Kharagpur is, where West Bengal is. They do not need to bother. What they will do, they will simply send it to the main collection center in India, okay, for the post, and they do not need to really care which city, which states, those sort of things. They do not really need to care. So the collection center in India will get it. They know where West Bengal is, so they will send it to the collection center for West Bengal. From West Bengal collection center, they will send it to Kharagpur. So you see that those internal organizational structure and organizational divisions, etc., or something analogous. So those things basically for the outside world, it is immaterial. They do not really need to know. So they have a packet to send. They will send to the appropriate higher level address, and then from that point on, the corresponding router, etc., they know how to handle that particular packet. Okay. So so the question is that why do you need it? Why do you need it? So think of, let us say that you have a router. You have a particular router, and that router connects to another internal switch or a router, which maybe is basically handles, let us say, 4 or 5 different smaller networks. Now let us say that outside router, it if you look at if you look at the corresponding routing table, then what will happen? So it needs to have, for the 4 different network, it needs to have 4 different entries in that routing table for it. Okay. Now, if you are talking about a big network, the number of entries in that routing table is going to grow accordingly, depending on the number of networks to which it is going to connect. So you don't need to do, you need to, in order to basically contain the size of, in order to contain the size of the network, okay, what you can do, not the network, the size of the routing table, what you can do is you can do something called aggregation. So in other words, those 4 routing table entries can be combined in certain way with the help of something called aggregation to have only a single routing table entry. So what essentially you are doing is you are cutting down on the number of routing table entries through the process of aggregation. Now this process of aggregation is called supernetting. Okay, supernetting. So now there are certain rules for this aggregation or supernetting. Okay, and these are basically these CIDR rules. Basically, these are the rules for CIDR as well. So these rules, sometime I believe I covered in the past, but in case I did not, so there are rules like, so how do you know like which all networks you can combine to form a supernet? Okay, how do you know? So there are 3 rules. The first rule says that all the networks that you are trying to combine, they should be contiguous. That means that the network ID should be contiguous. So that means that something like 200.1.0.0 would be one network ID. The next correct network ID should be 200.1.1.0. The previous one was 0.0. The next one could be 1.0. The third one could be 200.1.2.0. So this is again contiguous. And the next one could be, if we are talking about 4 different networks, 200.1.3.0. So in all of these, basically, as you can see that 0.0, 1.0, 2.0, 3.0. So that means that these network IDs are all contiguous. Okay. So this is the rule of the first rule. The basic rule of being contiguous is the basic rule of aggregation. So first criterion for aggregation, whether you can do aggregation or supernetting, this is the first rule. Now the second rule is that all the networks should be of the same size, and that size should be a power of 2 to the power n, a power of 2 basically. The size should be 2 to the power n. So all networks should be of the same size. And the third rule is that the network ID should be divisible by the size of the block. So by size of the block means what? The total number of IP addresses in that particular network. So you might be given a question where, let us say that you are given a couple of different networks, okay, with their corresponding CIDR address, like the example that I was telling you, 200.1.0.0/24, 200.1.1.0/24, 200.1.2.0/24, 200.1.3.0/24. So these are like the 4 different networks. Now the question that might be asked to you is that whether these networks can be aggregated or whether you can form a supernet out of these addresses, out of these address blocks. So the first thing, so you have to check whether it can be done or not. You have to check whether the 3 conditions that I just mentioned hold or not. What are those conditions? First condition is that whether it is contiguous. The next one is what is the size of the network? It should be a power of 2. Power of 2 to the power n basically should be the size. The third condition is that whether the first network address is divisible by 2 to the power n, right? The network ID should be divisible by the size of the block, so which is 2 to the power n. So like this, actually these different conditions are there. Okay, actually I wanted to show you with this example by hand, but I'm not able to. But I hope that if you follow my lecture slowly later on, you would be able to understand what I mean. But still, if you have doubt, now or later, please do not hesitate to ask. Okay, so this kind of question may be asked, when we are talking about CIDR supernetting. Another type of question that might be asked is that what is the supernet mask? There is a concept of supernet mask. Now, to get the supernet mask, what you need to do is that for each of these networks, okay, excuse me. So for each of these networks, you need to replace, basically you need to replace the fixed part. So you see that there are two parts, right? If you take each of these networks, so there is a part which is variable and there is another part which is fixed. So for example, 200.1.0.0. Okay, then the next one was 200.1.1.0. so the fixed part is basically this, the first 6 zeros, right, of the third octet. So what is the first octet? 200. Second one 1, and the third one, if you take, this is where all the changes are coming. Now within these changes, if you change that integer to the bits, basically binary, so 200.1.0, right? So what is this 0? 0 is basically 8 zeros. The next one is 200.1.1. What is 1? 1 is basically 7 zeros followed by 1, binary. What is 2? 2 is 6 zeros followed by 1 0. What is 3? So 3 is basically 6 zeros followed by 1 1. So you see that within these bits also, the first 6 bits, these do not change. So these are the fixed bits. So this, along with the previous two octets, that means 200.1, these do not change. So 200.1.6 zeros will not change. What is changing? Only the latter part is changing. So the first part is called the fixed part and the latter part is called the variable part. So in the fixed part, to get the supernet mask, what you need to do is you need to replace the fixed bits with all ones. And to get the variable part, you need to replace all these variable bits to be replaced by 0. So if you do that, you will find that this result, this exercise will give you 255.255.252.0 basically, if you do this exercise. How is this 252 coming? The third part, how it is coming? The first 2 bits, okay, and the latter how many bits? So first 2 bits, no, sorry, 255.255, yeah, you have replaced. Then the next 8 bits, basically, if you take, then you will get that it is 252. And the rest of the bits, if you put, these are all zeros, so you will get .0. So 255.255.252.0 will be the supernet mask. Now, let us say that some packet comes to this gateway router, right? So which is, which has this particular supernet mask 255, because we could do the aggregation, right? So we got through this particular exercise we could get the supernet mask. Now the supernet mask is 255.255.252.0 and we take that IP address that has come. Okay, so we can do an AND. I'm sorry. So this part basically no. So we'll not do the AND with the supernet. So let me revise what I just said. So let us say that so what is the SuperNet ID, right? So you might be asked, like, what is the SuperNet ID? So to get the SuperNet ID, what you need to do, you need to do a logical AND of the SuperNet mask with any network ID that you want to take from this particular network. So any network ID will be like 200.1.0.0, let us say the first network ID. And then you do a logical AND operation with the SuperNet mask that we calculated. So that gives us the SuperNet ID if you do this AND operation, which will be 200.1.0.0. So you see that what I have done, through some basic, calculations, I am able to replace these 4 different networks, okay, into one conceptual network, one logical network. So correspondingly, the router that connects to these 4 different networks, that routing table entry will not be 4, but it will be 1. Because as we know that corresponding to every network, the router which connects to these networks, they are going to have a routing table entry. Now these routing table entries, so if we are talking about a router connecting 4 different networks, it's going to have 4 different entries. Now what we have done, we have replaced that with only a single entry, so as to basically reduce the complexity of the routing table and reducing the number of entries that goes in to that routing table. Is this clear? So this process basically is called route summarization. It is called route summarization. So this is something I know that it might be a little difficult for you. The reason is that you are not able to, whatever I told you is all verbally. But please, because this video is, this thing is recorded, this lecture is recorded. Whatever I told you, please listen to it very carefully. Pause and listen like that later on, and try to work it out with the example that I told you, as well as any other example that you are able to find from the book or elsewhere. Okay. Now, so let us try to understand this concept. Let us say that you have some company with IP address this one, and let us say that this company has 2 units. So this is, let us say, 1 unit, and this is another unit. And let us say that each of these units connects to a router R2 and R3, and these routers basically have 4 subnets. These connect basically 4 subnets. So these 4 subnet units with their corresponding IDs, subnet IDs, etc., they connect to R2, and same thing for this one also. Now let us say that there is another router R1 that basically connects to R2 and R3. So you see that R1, if you look at its routing table, it is going to have only 2 entries like this. So any higher level router basically that it connects to will have just 1 entry for the 8 subnets. Otherwise, if this was not the case, what would happen? This higher level router would have had 8 entries. So what you have done cleverly, you have replaced those 8 entries with a single entry. So this is basically this supernetting concept associated with CIDR. Now these advantages I have already told you, please go through it. And one last concept that I wanted to tell you at this juncture is basically this longest mask matching. Longest mask matching. So what is this? Let us say that we have 4 organizations, organization 1, 2, 3, and 4. And let us say this particular organization is not co-located with these organizations 1, 2, and 3. Or you think of it this way, that IIT Kharagpur, has 3 departments which are co-located and 1 department which is located in Kolkata. Let us assume. Actually, it is there because IIT Kharagpur has campuses in Kolkata and Bhubaneswar. So let's assume that, so you need to do this kind of addressing and supernetting, etc. So you see that, so let us say that each of these networks, their corresponding IDs, these network IDs are given. Now you are doing classless addressing. Let us say that you are doing classless addressing. So if you are doing classless addressing, and if for some reason this network, it is, because it is not co-located or whatever reason, it cannot be really actually combined this way, then what you can do is you can take help of this longest mask matching principle. So in longest mask matching, what happens? You have, so before I explain that part, so have a look over here. Let us say that this is your network. You have two routers, R1 and R2, which are connected this way. So R2 connects to internet and R1 connects to R2 in this fashion. So if you look at the routing table for R1 and the same for R2, so routing table for R1, it is going to have these different network addresses, right, for corresponding to these different organizations or these departments or the units of the organization, right? So this will be the routing table for R1. The same goes for routing table for R2. How many interfaces are there? Two interfaces, right? So the routing table for R2 is also like this. Now, what is the concept of longest mask matching that we are talking about over here? So in longest mask matching, this routing is going to be sorted. Each of these routing tables is going to be sorted from the longest mask to the shortest mask. So let us say that if we are talking about these different masks, if there were three masks, 27, 26 and 24, the sorting will be like this, that the first entry is going to have the mask which has /27 and then followed by the other ones and /24. So it is going to be sorted in this manner. So look over here. So you see that the first one over here is /26, then followed by that is the /24. So for R2, the routing table will look like this, and for R1, the routing table to look like this. So these are basically the longest mask. Basically, the longest mask has to be matched. So for this, what you do is you sort it in this particular fashion. Okay. So why do you want to do it? The question is that why do we want to why do we want to match it with the longest mask? Because if you do not do it, that means the former case, basically, if you have something like this and you are not able to aggregate this particular organization, then basically, what is going to happen is you cannot, if you do not have this concept of longest mask matching, then this one cannot be aggregated with the previous one. So in order to be able to do it, so what you do is you start matching from the topmost address, and the maximum match, whatever network you get with the maximum match, so the packet is going to be sent to that particular network. So sometimes this is also called the prefix matching also, okay, longest prefix matching or longest mask matching, because the mask basically defines in classless addressing basically this prefix part, so that's going to define the mask, right? So that means the /24 is sometimes also called the mask. Okay, so we do not have a separate mask over here in classless addressing, that is why it is called that way. Okay, so this is one part. Another thing also, very quickly, let me tell you. So mind you that do not worry. Later on, if I find some scope, I will work out this example that I narrated just now for you, and I will be able to do it for you. Okay, so I will once again I will try to do it if I can get some time. Then अभी छोड़ो, टाइम भी हो गया. अच्छा, so let me close this part and let me explain one more concept, and then we'll be done for today. So this one again, Ria, please stop this recording and start the other one.